Okay, Assalamualaikum and good day. So in this video, I'm going to show you how to construct a one-way ANOVA table by using another formula that been provide this formula will be provide for you in final exam, right? So previously in our class we used this formula in SS to calculate sum of square total. We use double summation yij square minus y dot dot square divided by capital N. So to calculate another formula to calculate sum of square total, which is summation of xij minus x bar bar square. So this is the formula that we're going to look at in this video. So for summation of treatment or between group, right? Previously we look at this first formula, right? So in this video we're going to look into second formula, which is summation of ni multiplied with x bar I minus summation x bar bar square. So this is a formula that we're going to look this in this video lah. So these two formula will be shown in this video. So to calculate summation sum of square error is the same procedure as previous lah. Summation sum of square total minus sum of square treatment. If just to emphasize, sum of square error also known as sum of square within group, right? Sum of square treatment also known as sum of square between group, right? So since both formula require some x bar bar, so to calculate x bar bar, x bar bar is actually grand mean lah. Grand mean is actually average of all values when the factor is ignored, right? It is also known as weighted average of individual sample mean. So in this formula, we need to add all observation summation of xi divided by capital N. Capital N means that all member or all observation, number of observation in the sample, right? So of course this is the formula that I already emphasized just now. Previously we look at this one. Now in this video we look at the first formula, summation of xij minus x bar bar square. This is for sum of square total. For sum of square treatment, summation of n multiplied with x bar minus x bar bar, then we square. And then for sum of square error is actually summation of ni minus 1 multiplied with si square. Ni, it means that the number of sample in group, right? So if you have 3 groups, so let's say group 1 we have 4 sample, n equal to 4 minus 1 multiplied with the standard deviation. Standard deviation square means standard which is a variance, sample variance of the group lah. This is a sample variance, right? Okay, so next is the if you want to get the summation of error, so summation sum of square of total minus sum of square treatment. So now let's look at example number 1. In this example, right, actually this is a second example in our lecture note, right? In an attempt to speed up the cleaning process of oil spill in the sea, an experiment was carried out on 3 different methods. So the effective in cleaning up the oil spill will compare by recording the surface area cleared in 1 hour by each of the methods several trial. So the result are shown in this table, right, this value. So for method A, we have 5 sample and the average of the sample is 57. For method B, we have 4 sample. The average of method B is 59. For method C, we have 6 sample and the average for C is 57.33. So we want to construct ANOVA table, and given that the sum or square total is equal to 303.33. So to construct, we already have the first information, which is sum or square total, which is equal to 303.33. So we want to find sum or square treatment, or treatment also known as between group, right? So this is equal to summation of n multiplied with x bar minus x bar square. So in this value or information given, we don't have the value of x bar. So to calculate x bar, we need to get the total of xij, the summation of all value, divided by capital N. So from here we know that we have the x bar and n. So to get the summation of xi, it should be equal to x bar multiplied with n, right? Remember, x bar is equal to summation of x divided by n. So we do multiplication and manipulation to get summation of xi. So this is xa should be equal to 57 multiplied with 5. So this one should be equal to 285. So for the second one, summation of xb should be 59 multiplied with 4. This one should be equal to 236. And the last one, xc, 57.33 multiplied with 6. So we will get 344 basically, right? So from here, to get x bar, so we add everything, every summation. 285 plus 236 plus 344 divide by number of sample 5 plus 4 plus 6. So this one should be equal to 57.67, right? So now to calculate the sum of square treatment, right, we use the formula, which is n multiplied with x bar minus x bar. So this one should be equal to, the first treatment is 5 multiplied with x bar is 57 minus 57.67, which is x bar square. So plus 4 multiplied with 59 minus 57.67 square, plus the last one is 6 multiplied with 57.33 minus 57.67 square. So this will lead us to 10.0003. So we take 2 decimal point, 10.00. Right. For this information, we can construct one-way ANOVA table already. So in ANOVA table, we should start with the source of variation. Another one, we have sum of square, and we have degrees of freedom and mean square, right? And the last one is F value lah, right? So we put in proper table. Oops. Wait, let me use the shape. Alright, so the first one is treatment, or this one also known as between group, right? And then the second one is error, also known as within group, and the last one is total. Okay, so this one, put some space here. Alright, so now the sum of square total is 303.33, and sum of square treatment is equal to 10.00. Sum of square error will be 293.33. So how to get sum square error? Sum of square total minus sum of square treatment. Right, so the degree of freedom for sum of square total, so we look at the number of sample size. We have basically 15. Capital N equal to, this is capital N equal to 15, right? So degree of freedom here is n minus 1, so be equal to 14. And some degree of freedom for treatment is k minus 1, so k we have 3 group. 3 minus 1 is equal to 2. And then we have capital N minus k, which is equal to 12, right? Or you can simply minus sum of degree of freedom total minus degree of freedom group, right? Treatment. So you will get 14 minus 2 equal to 12. So the mean square treatment is simply sum of square treatment divided by sum of square degree of freedom. So this is equal to 5, and degree of freedom, mean square for error is 293.33 divided by 12. So this is equal to 24.44. To get the F value, 5 divided by 24.44, or mean square treatment divided by mean square error. So you will get 0.2045. So this is how we use the second formula to construct a ANOVA table. So the next procedure to test whether there is a significant difference, we will use the normal procedure lah, right, as we have learned in class. So in this video, I just want to show you how to use another formula to construct a one-way ANOVA table, right? So now let's look at another example, which is example number 2. In example number, this video, example number 2 in our class, this is same example in example number 3. So an experiment was run to determine whether 4 specific firing temperature affect the density of a certain type of brick. Right, a completely randomized experiment lead to the following data. So we have temperature 100, temperature 125, temperature 150, and temperature 175. For temperature number 1, 100, so n equal to 5, x bar equal to 21.75, n equal to 4, x bar equal to 21.5, n 150 equal to 5, and x bar 150 equal to 21.72, n 175 equal to 4, x bar 175 equal to 21.7, and let SST, which is equal to sum of square total, this is a sum of square total, right, equal to 0.5161. Right, since we already have the sum of square total, so to compute the sum of square treatment, so we're going to use a summation of Ni x bar minus x bar bar square. So x bar for each treatment we already have. So we need to calculate x bar bar. To calculate x bar bar, we can use a summation of x 100 equal to 21.74 x bar multiplied with the sample size equal to 5. So this one should be equal to 108.7. For second one, summation of x 125, this is 21.5 multiplied with 4, which is equal to 86. Summation of x 175, 21.72 multiplied with 5, this one should be equal to 108.6. And the last one, x this is 150, sorry, this is 150, 175 equal to 21.7 multiplied with 4, so this is equal to 86.8. Right, to calculate x bar, so 108.7 plus 86 plus 108.6 plus 86.8, divide by the sample size, 5 plus 4 plus 5 plus 4. So this will lead you to 21.67. Alright. So to calculate the sum of square treatment, n equal to 5, the first treatment, x bar is 21.74 minus 21.67 square. And we go to until the last one. So this is 4. 21.5 minus 21.67 square plus 5 multiplied with 21.72 minus 21.67 square, and the last one is 4 multiplied with 21.7 minus 21.67 square. So this will lead us to 0.1562. So by this value, by this computation, we can calculate sum of square error. So sum of square error is a sum of square total minus sum of square treatment. Right. So this one should be 0.5161 minus 0.1562. Okay, so now we can calculate, we can construct the ANOVA table lah. So ANOVA table start with source of variation, and then we have sum of square, degrees of freedom, and then we have mean square, and last is F value lah. Right, let me draw the layout for the table. Okay. Right, for the first row we have treatment. Treatment, remember, also known as between group. Right, and then we have error. This is also known as a within group. And the last one is total. So we know that sum of square total is 0.5161. Sum of square treatment is 0.1562, and for sum of square error, we minus sum of square total minus sum of square treatment should be equal to 0.360, right? So we have 4 treatment. So for degree of freedom treatment should be k minus 1. 4 minus 1 is equal to 3, right? And we have basically how many observation we have? We have 518, capital N equal to 18. So n minus 1 equal to 17. So this one should be n minus k. So 18 minus 4 equal to 14. Or we can simply minus sum of degree of freedom total minus degree of freedom treatment. So to get the mean square treatment, 0.162 divided by 3. So this is 0.0520. And the second one is 0.36 divided by 14. 0.0257. To get the F value, mean square treatment divided by mean square error. So this is 2.0233, right? So this is how we use the second formula to compute or to construct ANOVA table, right? And of course, the next procedure to find the hypothesis testing are same as in class. Alright, I think that's all. Thank you very much. Assalamualaikum.